First, we're going to be locating our camshaft and crankshaft position sensors on the vehicle. This is our 2005 Suzuki Verona. And here at the top of the engine, next to intake manifold, we have our camshaft position sensor. And back here at the back of the engine, we have our crankshaft position sensor.
So our camshaft position sensor is using a magneto-resistive type sensor, and our crankshaft position sensor is using a variable reluctance type sensor. Here's the wiring diagram for our Suzuki's crankshaft position sensor. Here, the dark blue and white wire is going to be our VREF wire. The yellow and black wire is going to be our low reference. And then the dark green, or in this case our black wire, is going to be our shielded ground wire. So for our crankshaft position sensor connector, our pin number 1 is going to be our blue and white wire. Our pin number 2 is going to be our yellow and black wire. And our pin number 3 is going to be our black shielded ground wire. On all data, it says that this wire is supposed to be dark green, but in our case, it is black. Here's the wiring diagram for Suzuki's camshaft position sensor. Our pin number 1 is our brown and white wire, which is our signal. Our pin number 3 is our pink and black wire, which is our positive 12 volt. And then our blue and black wire at pin number 2 is our low reference. That is shared with the intake air temperature sensor. So for our camshaft position sensor connector pinout, our pin number 3 is going to be our pink and black wire. That wire is going to be for our positive 12 volts. Our next wire is going to be our blue and black wire at pin number 2, which is going to be for our low reference. Our pin number 1 is going to be our brown and white wire, which is going to be for our signal.
So this is our crankshaft position sensor AC voltage reading because it's a variable reluctance sensor. And we're gonna rev the engine. And we can watch our AC voltage reading increase. For our camshaft position sensor, we're currently reading about 6.9 hertz because if we were to measure in volts, we'd be getting an average of about 2.5 volts in between 5 and 0. We're reading in hertz because we have a 3-wire sensor and we're getting a digital signal. Now David is going to rev the engine and we're going to see how our hertz reading changes. Go for it. As you can see, our reading increased by a pretty large amount. So we have the picoscope hooked up to our 2005 Suzuki Verona. We have our red B lead hooked up to our camshaft position sensor signal, and we have our blue lead connected to our crankshaft position signal. And we can look at our readings, and here you can see our camshaft on and off time. It's duty cycle controlled 50%, and then we have all the teeth on our crankshaft position sensor, and as you can see, if we pause it, you can see we have a full engine rotation and the missing teeth on our reluctor wheel. Now we're going to be revving the vehicle. As you can see, when we rev the vehicle, our crankshaft position sensor voltage increases and our frequency for our camshaft position sensor decreases.